Okay. Now I'm gonna start with number one.
Hey!
It's Scousy here. So I'm gonna be doing number one. On the I don't know what pages it is. It's 137 and the integral of cosine squared for x dx. I've been informed that it's 793 or what is everything. So this is the problem. I will be copying it down. It is sine cubed x cosine squared x dx. It was t, but I didn't write it as t, so screw t. So if you look at the useful integration techniques for like whatever certain problems, it says that if you have a situation like this, you should split it up into sine x and sine squared x and cosine squared x dx. I'm attempting to communicate with them, not with you. And so it also says in like cases like this that you were supposed to use substitution for cosine x. So I set u to cosine equal to cosine x, and du is equal to negative sine x. And so what you do is, because you don't have du yet.
I have a question.
Yes.
I don't see any cosine x.
I hate you. So whatever. I'm just gonna sine x squared cos x squared dx. You're welcome. So you multiply that at negative 1 because you want to find du. Just in here somewhere. Okay, and then what you find is you have negative 1 times integral of sine squared x du. And so from that point, this is what I did. I think this is right. I did this. Sine squared x is equal to 1 minus cosine squared x, because we all know that, of course. And so what I did was negative 1 times the integral of u squared times 1 minus u squared du. Yes. Well, because the cosine is equal to u. So it's u squared, not u. It's u squared. But thank you for that catch. And so it's u squared, so it's negative 1 times the integral of u squared times 1 minus u squared times du. And so I just multiplied that out. So it was 1 times the integral. Yeah, exactly. Integral of u squared minus u to the fourth du.
Is that u to the u?
U fourth. I said it. You heard it, Jack. And so negative 1 times negative. No. Yeah. Wait. Oh yeah. No. It's just it's just 1 over 3 u to the third minus 1 over 5 u to the fifth, and then plus c. I just reordered it, so I just made it 1 over 5 u to the fifth minus 1 over 3 u to the third plus c, and it's 1 over 5 cosine t if you want, but I'm just going to leave that x to the fifth minus 1 over 3 cosine x to the third plus c. And in the book, the answer is written as, it's like c times something like this. Well, in the book it's written as, or no, that's not what it's written as. It's written as, yeah, I was about to, cosine x fifth, or all over 5, minus cosine x to the third, all over 3 plus c. And it was written with like a c in front of this, but does it matter? Okay.
I like your answer.
Sweet.
Why was there a C?
Zoom.
They just, because technically that's a constant, so he was saying they were taking it out, but I would do it.
It's 5, sorry.
I
What
tried
was it?
to, but I don't know. It's different or in the back. One twelve sine equals 3 theta to the fourth power.
You're welcome, Lucas, and
What?
Emily, and Jake. And I think that's all.
Just keep shouting people out.
You're welcome.
Okay, so hit stop till the next person moves up.
Everybody know that Max is a loser.
Hey, you have to be nice.
Can I have an apple?
Wait, how many goals did you score last night, Jack?
Say, can I have an apple?
Yeah, that's what I thought.
Say, can I have an apple?
Go back up.
Luke knows Jack scored 0 goals last
Okay,
night.
you're wasting your time.
I'm just trying to get an apple.
I just scored.
You're working upon that.
That's the
Who eats
Who
an
won?
apple?
Jack shot like 30 yards out. He bounced it and left it in.
I got an apple.
Yeah, every.
You argue with everything. As if it's legitimate, when it's clearly not.
Jack, are you hungry right now?
Yeah. Wait, what?
He's recording.
He's talking.
It doesn't matter, they can't hear him. They hear you. Actually, they don't.
Okay. Number 3 is written as the integral sine cubed 3 theta cosine 3 theta d theta. And if you just look at the problem, then you see that the derivative of whatever's in the inside here is also in the problem because the derivative of sine is cosine. So then you just say, yeah, it's equal to sine 3 theta cubed, you know, just to clear that confusion up. Cosine 3 theta d theta. Set this as u. Derivative of that. Cosine 3 theta times 3 d theta. So then you're missing a 3 in here. So you got to make it 1/3 on the outside. And then it's just like u cubed. Well, I'm skipping a step because I like to. But if you added the 1/3 in here and the 3 in here, then that's where it would be. So then you just take the derivative, or the integral. My bad, team. So it's 1/3 times 1/4 u to the 4th. It's equal to 1/12. Substitute in your u. Sine 4 3 theta. Add that little plus c in there.
Pause the recording.
Ooh.
So this is problem number 7. What's odd about problem number 7 is it has this theta squared all the way through it. So I'm actually going to handle that first, and this one might even come out with like a double U substitution, I'm not sure, but I'm going to just handle that to start with, the fact that I've got this theta squared. What would du be? Do I have 2 theta d theta? Alright, so I need a 2 and a 1/2. My ladybug's covering my 2. Okay, so this stuff right here is my du. Okay, so I'm going to have 1/2 tangent cubed u secant to the 4th u du. So I'm just kind of trying to get rid of the confusion from the theta squared, because it's clearly not just a theta. Now, what was one of the techniques they said if you got a bunch of tangents and secants? What can you break off? Yes, okay, so you can do a Pythagorean identity substitution, but usually before you do that, you can break something off. What can you break off? That's it. Break off a secant x tangent x. So that's what I'm going to do. So if I break off a secant and a tangent, the power of each one of these would go down by 1. Okay, so I just took one off the secant and one off the tangent. Now, what is it that if you take the derivative of it, you get secant tangent? There is secant, secant tangent. Okay, so that would help me for this part, but it wouldn't help me for this part. So that's where I'm going to use the substitution that Rachel said for the tangent squared. So what's the Pythagorean identity substitution for that? Can you say that again?
Tangent squared equals secant squared minus 1.
Okay. All right, so he's given it to me. Yeah, he already solved it for what I needed. Okay, thoughts on what I can do with this?
Distribute secant.
Distribute, okay. So I would have secant to the what? Fifth, because you add your exponents. And basically from here you're doing a power rule. This being the derivative of the inside. To make it more clear, I'm going to separate it into two separate ones, two separate integrals, but it's not really necessary. This would be like having the integral of secant u to the fifth times secant u tangent u du minus the integral of secant u to the third times secant u tangent u du. And you don't have to write it out separately as long as you understand what's going on. Basically, you've got another u substitution. Okay, so if it was a v substitution, what would v equal? And dv? Okay, because the derivative of secant is secant tangent. So if we rewrote this, and it's the same u substitution over here. Works for the second one, so I'm not going to write it out again. So this would be v to the fifth. All of this is dv minus v to the third. All of this is dv. So you've got 1/2. This would be 1/6 v to the 6 minus 1/4 v to the 4th. We could. So 1/12, you want to put what v is? Do you want to also put what u is? Oh, I don't need that parentheses. Well, that's right. Yeah, so if you'll remember, the last one was this, and I just added it on. I'm not going to work it all the way out, but if you'll remember, when we solved cosine squared x, it was 1/2 1 plus cosine 2x. So you're going to be doing cosine squared 4x. So what would that be equal to? Yep. So these just have to be double. So you just need to change this to be integrating 1/2 plus integrating 1/2 cosine 8x. And you should be able to do that. And that's a very common substitution. I would expect to have to integrate cosine squared of something on your next test.
Good morning, class. Today I will be doing problem number 65, as you can see here, which is written as taking the integral of x times 5 to the negative x squared dx. So first of all, what you're going to do is you're going to... The whole class is laughing, and it's making me feel very self-conscious and bad about myself. I'm going to cry. Okay, so you're going to want to set u equal to negative x squared, which is that little exponent right over here. Let me move this down just a teeny bit. Okay, so u equals negative x squared, so that means du equals negative 2x dx. So what you're going to do now is you have your u right there, so you can go ahead and write x times 5 to the u dx, and so since du is only negative 2x dx, the only thing you're missing over here is the negative 2, so you're going to slap a negative 2 right there, and a 1/2 over here to counter that. Oh, that's true, it is a negative 1/2. Shout out to Jack Poss, my best friend. He's just chilling over there. Okay, so you got negative 1/2 times the integral of 5 to the u du. So from there, let's see, what you're going to do is you're going to integrate that. So you're going to have negative 1/2 times 1 over ln of 5 times 5 to the u plus c, because that's how you take an integral and all that good stuff. So then you're going to have, if you multiply by the negative 1/2, you're going to have negative 1. Oh, apparently I'm whispering. Okay, I'm going to talk a little bit louder now. Can you guys hear me? Do I need to re-explain anything? Is everyone all good on this?
Are you asking Mike?
I'm asking the class and the mic. I'll explain to people in the mic.
You're fine. Keep going.
Okay, so you've got negative 1 over 2 ln of 5 times 5 to the u plus c. And then you're probably going to have to substitute in that u, seeing as it's a u, and you know what u equals. So you're going to have negative 1 over 2 ln of 5 times 5 to the negative x squared plus c, which can also be written as negative 5 to the negative x squared over 2 ln of 5 plus c. And that is all for today. Class is terminated now. Oh yeah, we're done with homework, not with the actual class. Max wants me to give him a shout out.
We should probably answer hers.
Oh, okay.
Which one is it?
Well, I'm up here to do it. Hey guys.
It's a three-way.
We got David and Max and Jack on the mic. We're the European Migos.
3 Musketeers.
Tim has to get up here instead of Jack, then it'd be European League.
Okay, just do it.
You talk while I write.
Oh, okay, so you're integrating from negative 1 to 2. Got 2 to the power of x dx.
What's right here?
Ow.
Yeah, for real, just making...
Okay, good morning, lads. So, Jack is working this here problem. Say hi, Jack. I will be speaking for him because he's a mute little boy. Okay.
Hey, get Max on the mic.
Oh, what's up, Max? Say hi.
What's up, guys? I'm just standing up here. I'm not really helping or providing anything.
He's just cool. He looks cute, though. You look good today, Max.
Thank you, dude.
Alright, so Jack is he's integrating this little doohickey right here. So he's got 1 over ln of 2 times, 2 to the x. Ooh, Jack, wow.
Where do you put the...
Oh, Jack, what are you going to do? Oh, he's going to put the other bracket and add those little, add the domain, I guess? I don't know. And then you're going to have, what are they called? The bounds, the boundaries, right. So you got 1 over ln of 2 times 2 squared, because you're going to want to put in the top bound and then subtract it by whatever you plug in the bottom bound for.
Yeah, it's 2 to the
I'm
negative
missing
1.
something.
It's 2 to the negative 1.
Yeah, Jack is a fool.
That's how I messed up.
Just erase it. It's a erasable pen.
I really don't like pull erasable things.
Well, the eraser really doesn't like you.
Jack said he didn't like the erasable pen, and Max said the erasable pen does not like Jack. In case you couldn't hear it, it was a little traumatic, and I feel for Jack right now. Alright, so you
pretty much got
can do some subtraction right there.
ln2
Minus. Why do you have the brackets?
So he can go...
Done.
Now, just to be cool, we're gonna multiply both these by 2 equals
Jack
7
said just to
over
be cool, he's going to multiply both of those. It's going to bring them to a common denominator. The common denominator being 2ln2. So you're going to multiply this over here by 2. So you get 8 over ln of 2 minus 1 over 8 over 2 ln of 2 minus 1 over 2 ln of 2, which equals 7 ln of 2.
Could you do anything with the 2L and 2?
Yes.
Yeah, okay, so you got 4 over ln of 2 minus 1 over 2 ln of 2, right? So,
Show the 2 over 2.
oh, you don't multiply it. Wait a
You
second.
did it right. You explained it correctly.
Okay,
But show
so-
the 2 over 2. Go ahead and multiply it times 2 over 2.
How do you make the pen come out? Whoa, that's crazy.
Show the difference between the 1 ln of 2 and the 2 ln of 2. Like, where do you get those two different things? You know what I'm saying? Like, I get the ln of 2, but that's just there.
Get back up here, Jack.
Okay.
Where's the 2?
We got a couple questions about
Where's
this.
the 2 ln of 2? This is 2 to the negative 1. 2 to the negative 1 is equal to 1 over 2. So this is times 1/2, so then you just have 1 over 2 ln of 2 here. And over here, you multiply by 2 over 2 to get a common denominator here so that you can combine them. So it's 8 over 2 ln of 2 minus 1 over 2 ln of 2. Do your little math. 8 minus 1 equals 7. Quick maths. And if you do your little logarithms rules, then 2 ln of 2 equals ln of 2 squared. That's just something you can do if you want to be real tricky.
Yeah.
Could be 7 over L.
I hope all of you that missed this class are having a good day. You're not too far behind.
You gotta tell the kids
It's
to
beautiful
watch the first
Thursday.
23 minutes.
I mean, that gives it
Those are the
it's
most-
just combining like terms.
Thank you.
But the other ones were great. Because I got there, I just didn't think.
Okay.
Yeah.
I'm gonna
But now
go
you
now.
did, so you might as well.
Bye.
Yeah.
Okay, so that's all the homework questions. This is the new lesson for today, and it's not too long. Next time's lesson is kind of a big deal. Just going to warn you, so get well and whatnot. No, next class. Don't get sick. Thursday's kind of rough. Okay? Thursday's the most vicious of our integration. Today is not too bad. Yes, you can turn the homework in if it's done. All right, so if you remember, a long time ago, back in derivative land, we took the derivative of arc sine, arc cosine, and arc tangent, and those are the rules right there. Okay, but here we have the rules going backwards. Notice that we have 3 rules for derivatives, but only 2 rules for integrals. Okay, so we're going to try to figure out what that is. Okay, so if you look on this one, let's just take this one for example. Okay, the derivative of arc sine is 1 over the square root of 1 minus x squared. So if you go backwards, the integral of 1 minus x squared would be arc sine x. So they've got that here. It's just they did it a little bit more general. Remember that a represents a constant. So in this rule, that'd be like 1 squared, but they're saying you could have a different constant squared here. So when they did this rule backwards, they got this rule. Now I don't see an arc cosine rule backwards, do you? Why do you think?
Negative.
Yeah, it's just the same thing, only negative. So anything that I could use an arc sine on, if I'm integrating, anything I could use an arc cosine on, I could use an arc sine or vice versa. So they don't provide you with another rule because you don't need it. You could do it, it would work. Okay. And then they did this rule backwards. So the derivative of arctan is 1 over 1 plus x squared. So if you integrate 1 over 1 plus x squared, you would get arctan x. They gave you a little bit more general rule with a constant. Okay, so these are your 2 new rules for today. There are more rules. There's like a arc secant, but they don't give it to you. But the fact that they don't give it to you, they also don't make you use it. So it's not too big a deal.
Can you scroll over a little bit? I see the absolute value of x is less than.
And those are on your formula sheet. You will definitely want your formula sheet on the next test. Every test. So, all right. So we're going to take a look at this first one. And basically you only have 2 choices for rules, new rules, but you can combine it with anything else we've learned at all. Okay, so I've been told this looks more like an arc sine. So if we look up here in the arc sine, definitely the x is just x, so it doesn't look like a u substitution. What about a? Yeah, so they're just doing it with an a of 2, and you don't really need a u substitution. Okay, so when you integrate this, you might want to write it as 2 squared minus x squared, just so it looks perfectly like this, but it's in exactly the right form. So I can just go to writing the answer. This would be arc sine of, what do you think? X over 2, or 1/2 x, plus c. So I'm just doing exactly the formula, because there was no u substitution for the x, and I just had an a of 2. So, okay?
It can't be this simple.
You're correct.
Good. And not good.
You have to write that absolute value of x.
No, that's just a limitation on the whole thing. You do not have to write it. So the question was, do you have to write this? And you do not. Okay, so on this little guy right here, which one does it look more like? Looks more like an arctan. I have to tell you, arctan is one of their favorite ones. So it's going to come up a lot this year and next year. Year 2 people, they'll guess arctan like all the time, because it's just something that comes up a lot. Yeah.
What exactly is arc?
It's the inverse tan. So like, it's the same thing as arctan. I just wrote the same thing. Tan inverse. So if you'll remember, hang on one second. So like, if you take the tangent of, say, let's say you take the tangent of pi over 4, because that's an easy one. Does anybody know the tangent of pi over 4? It's just 1. Because pi over 4 is the spot on the unit circle where it's square root of 2 over 2, square root of 2 over 2. So tangent, you just divide those. So if I ask you tan inverse of 1, I'm asking you, it's pi over 4, it's asking you what's the angle that has a tangent of 1. So it's just going the opposite way. But arctan and tan inverse are the same thing. Okay. So this is one of their favorite ones. It does look the most like this. It does kind of look like a u substitution. It kind of depends how you want to look at it. You can just write it in this form. Okay. So the question was, what do I do with the 9? First of all, let me deal with the a first. What do you think about the a? Yeah, you just have to say it was the square root of 2 squared, because we want it to be something squared. And then we want this to be something squared. So is 9x squared, is that something? Yeah, it's like 3x quantity squared. So really, in this case, we do have a u substitution, because instead of x, they put 3x. Okay, so we've got an a of the square root of 2, and we've got a u of 3x. And that's important because basically you need your du before you can integrate. So du is what? Okay, and so we don't have the 3, so we'll put a 3 and a 1/3. Okay, and then we'll rewrite it. So it'll be 1/3. This part is just my du. You want to go ahead and make that, I guess we'll go ahead and put that a squared plus u squared, yeah. And that's just exactly the rule. Okay. Is it okay? No, but yeah. Slow down.
You said it does not matter if there's an absolute or a square root of something that you cannot
The square root what?
There's a square root in the denominator. So that's
Right, you're allowed to leave a square root in the denominator. You don't have to rationalize for IB. Okay, so this would just be 1 over A arctan U over A plus C. And then all we have to do is substitute back in the U and the A. Do you want to distribute the 1/3 at the same time? Okay, so it'd be 1 over 3 square roots of 2 arctan 3x over the square root of 2 plus C. What do you think?
what is the 1 over A?
Just the rule. Yeah. So I didn't prove the rule to you. I'm just using the rule. Yes. All right, so this is the next question. My question to you is, which one, now here's the advantage you have in this lesson. You know what rules I'm trying to use. But in reality, you wouldn't know. You'd have everything mixed together. But out of the two rules we have, which one does this look more like? This one or this one? It's more like this one because it doesn't have a square root. That's all. So we're hoping that the denominator is a constant squared plus some kind of variable expression squared. Okay? And the fact that I have this random thing in the numerator, I'm hoping that's part of the du. Okay? So that's kind of my goal there. So I'm going to rewrite this. I'm going to leave the e to the x and the dx. But I want to write this so that it looks like a squared plus x squared. Doesn't really matter the order. So thoughts on that? Okay, 3 squared first. What about e to the 2x? Is that something squared? Yeah. So that'd just be like having e to the x squared. My dx is making that look a little ugly. Okay, so e to the 2x is just the same as having e to the x squared, because when you raise to a power, you multiply your exponents. Okay, so I think I can go ahead and define what my a is and what my u is. So a and u. Yep, du. Do I have it?
Yes.
Ooh la la. Yes.
So it doesn't matter which one is A and which one is B.
Well, a represents the constant, and u represents the variable. Only thing I was saying doesn't matter is it doesn't matter if I write a squared plus x squared or x squared plus a squared, but it does matter which I call a, because the position is different in the answer. So a is whatever the constant, and the u is going to be the variable expression. Okay, so all that's my du. Oh, I should have written it here. So if I rewrite this, it's the integral from 0 to ln of 3 du over a squared plus u squared. Okay, so I've got bounds. I'm not going to need a plus c. So just go to my rule. My rule is 1 over a arctan x over a. So for me, that would be 1 over 3 arctan. And then instead of x, I'm putting u. It's over a. Oh, that looks a little gross. Oh, why did I do that? I'm so sorry. I thought it was going to be 1/3 and I was going to be all cool and turn it to 3. I just made that up in my brain just to have fun. It wasn't right. Yeah, that's just a 3. I'm sorry. It would have been fun, though. Yes? Why did I put u in the x spot? Because remember, whenever you are substituting something in instead of x, that's what you make your u. So basically here, this was in the same form as this, only with u instead of the x. So that's why the u goes there. Does that make sense? Alright. So now all I have to do is substitute in bounds. So this would be, oh, and I'm using up part of my room for the other problem. But 1/3 arctan This would be e to the ln of 3 over 3. Okay, I'm substituting in ln of 3 in for that. Me too. Minus, oh, the comment was, I think that's going to be something funky, and I was agreeing. So minus 1/3 arctan e to the 0 over 3. Yes. So the question is that just 1/3? Yes, it is. And actually, arctan of 1/3 I can't do anything with. What I mean by that is it's not a unit circle value. So I can find the angle whose tangent is 1/3, but I would have to do it with a calculator, so I'm going to leave it just like that. Whereas this one's going to turn into something I know. Yes. Once you've integrated, it can go either way as long as you're consistent. But in general, with calculus, the rules are based on, like when you integrate, the rules are based on radians. So in general, for calculus, we use all radians. E to the ln of 3, what is that? 3. Because e and ln are inverse functions, so they undo each other. So that would just be arctan of 3 over 3, which would just be arctan of 1. And that is 1, I know. What is the angle whose tangent is 1? Pi over 4. Okay, so you could just call that pi over 12 minus 1/3 arctan 1/3. So it's not a unit circle value. You're not expected to substitute in for it. Okay, so for the next problem, I kind of took up all the room because I went on quite the travels for this one. So I'm just going to write this problem at the top of a piece of paper and start from scratch. Yes. Okay. I had a suggestion that this one could be arc sine. I'm just going to move that up here. And it does have some things about it that look like arc sine, so I feel like I'm going to use arc sine at some point. Is there anything that makes it look like you're concerned about using arc sine? Yeah, this x plus 2 in the numerator, like, I just wish it wasn't there. Don't you? I mean, yeah, if it just wasn't there, this would be good. It'd just be perfect, arc sine. What you're actually going to have to do on this one is split it into 2. Because you could call this x over the square root of 4 minus x squared plus 2 over the square root of 4 minus x squared. Okay, because if you add this plus this, you would keep the same denominator and add across the top. So does that look okay? As far as the first statement being true? Now, which one of those looks like an arc sine and which one doesn't? One on the right looks more like an arc sine because it doesn't have anything in the numerator. It's okay to have something in the numerator if it looks like your du, but on this one, x is just x, so it doesn't really have a du besides dx. So I think this is going to be a straight arc sine. So hopefully I know how to do this one some other way. Thoughts on how I could do this one? It is going to be u substitution. What am I going to need to do? What would be u? Okay, because it's to a power, right? And you can also bring that up, is what I would do. But du, we'll go ahead and do that, is what? Okay, and do I have it? I do. I need a negative 2, so I'll put the reciprocal there. This is only applying to the first part of the problem. So if I rewrite it, I'd have negative 1/2 integral. All of this is just du. And what do I have in the denominator? Okay, so I could say square root of u, or I could say u to the 1/2. Either way. Go ahead, and now what? Now some people, I hate to give Sydney any hints, but some people looked at this and thought this was an ln on the test because they saw 1 over something. But that only works if it's 1 over what? X. or 1 over u, or something like that. What do you do if it's raised to some different power? Bring it up. That was multiple people. But you would have had to have gotten all the way to there. Okay, so I had some people think that was ln of u to the 1/2 or something like that. Okay, but remember that only works if that's to the power of 1. Otherwise, it's a power rule. What other half? Well, that's all here. I'm going to deal with it later. But yes, I will have to. Okay, so then power rule, add 1 to the power, you'd have what? Times the reciprocal? Okay, so that would just be -1. Go ahead and put the u back in. And so we basically just worked the first part all the way down. So now we're going to work this part, and we said that looked like an arc sine anyways. Okay, so if we rewrite it, I think I'm just going to call it the square root of 2 squared minus x squared. Just so it looks like this, I can tell what my a is. So my a is 2. My x is just x, so that means I don't really need a u substitution. What about this 2 in the numerator? Let's do it. Yeah, we got that power. Okay, so I really don't have to rewrite. I can just, since it's exactly in the right form, I can just do arc sine of x over 2 plus c. So I'm going to actually just zoom on down here. It's a highly technical term. Share with your friends. Make the world smart. Okay, so this is the last problem, and I told the class it's a doozy, and again, since I've gone scattered, I'm just going to start fresh, nice and fresh. Could you distribute? Yeah, but it'll make it worse. It's not like against the rules or anything. They've actually separated it to be nice to us. Can this one? Yes, I'm listening.
I'm just saying, is it going to be arc 10 or arc sine? Because it has a square root, but it's only
Yeah. So what do you think? Any votes for arctan? Any votes?
I think arctan.
Okay, I agree. Arctan. Basically, though, if I'm going to do it, I'm kind of hoping this junk with the square root, I'm hoping that has to do with my du. So if I just want to kind of focus on this, and if I'm trying to make it an arctan, I will tell you sometimes they'll give you a hint on the substitution for this kind. And there's one, I give you a hint when I tell you to do it, but I think the book gives you a hint too on one that's similar to this. So sometimes they'll give you a hint like what your u substitution would be. But I'm going to rewrite this just a little bit. And given that you guys are thinking it's more likely arctan, then the 1 plus x, if I'm trying to make that look like the a squared plus x squared, what could I make that? What would be a? What would be x? So it's like 1 squared plus square root of x squared. Okay, so that would kind of look like it. And if that was the situation, what would u be? Square root of x, because that's what I'm putting instead of the x. Now, they may sometimes tell you that much of the substitution to try to help you get there. So this would be x to the 1/2. So what would du be?